Starting the chapter with trigonometry. Trigonometry is one of the most easiest chapters. If you are actually taught well and explained well, it's actually one of the very easiest chapters. Okay, it's just that the school starts the chapter by saying, the teacher started, this is one of the most difficult chapter, and if you are not able to understand it now, you will understand nothing in your future, and all and so on and so forth. Okay, so I would want you to understand what basic trigonometry is. Okay, the first two parts of trigonometry we have already completed. That is about the ratios. You have three ratios in here: sine, cos, and tan are the ratios that you have spoken about. Okay, now we also know that the trigonometry deals with a right angled triangle. So here in a right angled triangle, we have been applying the Pythagoras theorem all through our lives, but now we are going to apply these things as well. Okay, and if I'm particularly talking about any angle in here, the angle will be denoted with the alphabet theta. Okay, so sine of theta, these are angular ratios. Okay, these are ratios that can be found out using the ratios of the angles, sides, sorry. This is an theta is an angle. Actually, what is theta? Theta is an angle which can be found out using the trigonometric ratio, which is usually done with the sides. Okay, now sides upon sides. Now you may say, what is it? So if I'm talking about this side, and let's name it as L, M, N. Okay, then if I have to find sine theta, then how are you going to do it? This is the theta, so this side will be called as opposite. Okay, and this is called as adjacent. This is the hypotenuse, because this is always opposite 90 degrees. So the sine angle is opposite upon hypotenuse is what I have in here. Okay, opposite upon hypotenuse is what I have in here. So what is the opposite side? So length, whatever the measure of mn is, that will be written in here, and divided by the hypotenuse, that is ln, is what I'm going to write it, and find the angle and so forth. Okay, and in the second exercise of the chapter, we have dealt with finding the angular values for each of them. So I have sine, cos, tan, then I have cot, secant, and cosecant are the angles, trigonometric ratios that you have. Now I'll tell you one thing. Now the order that I have written is this: sine, cos, tan, cot, secant, cosecant. Why is that so? Because cot is the inverse of tan. So if I'm talking about cot, what is cot actually? Cot of any angle is 1 by tan theta. Okay, likewise cos is the inverse of secant. Okay, so cos theta is the inverse for secant. So if I do secant, that is 1 by cos is what I have. Then I have sine. 1 by sine is equal to my cosecant theta. Okay, this is secant. C-A-N-T. This is cosecant. Okay, so this is the inverse of this. Now what I am going to do is, I'm not forcing anyone to learn any of the values of this. I have a very different method of learning the values. I created this for myself, and I think it's pretty much easy for us to remember. So that the angles that we deal with is 0, 30, 45, 60 and 90 degrees is what we are going to deal with. Okay, so sine, starting with sine, if I just remember sine, I can write down the full table. So sine is 0 to 1. It ranges from 0 to 1. And then abhi mujhe 30 ka likhna. So what I'm going to do, I'm going to do half of it. Somewhere between 0 and 1, what exactly is there? If I have 0 here and 1 here, exactly in the center I have an half. Fine, I've written that down. Then after 45 degrees, what is the value? The same value repeats, 1 by 2, but it cannot be the same value. So I'm going to put a beautiful hat on the 2. Okay, the root I'm considering it as a hat. Okay, then 1, 1, 2, 2, 1, 0, all of it is there. I cannot put another 0 here. I cannot put another 1 here. If I put, let's say, if I put the same 1 by 2, this is already having the root, cap or hat. If I put, it will still become 1 by 2 only. Okay, so this is not possible. So what I'm doing is, I'm taking 3. थोड़ा सा different रखने के लिए I'm taking a 3 upon 2. But 3 को अभी 3 is jealous. It also wants a hat on its head. So this is your sine value: 0, 1 by 2, 1 by root 2, root 3 by 2, and 1. Finished. Then after cos values, how am I going to write cos? Cos will be written in the reverse order of sine. Cos is reverse order of sine theta. So this 1 root 3 by to 1 by root 2, 1 by 2 and 0 is what I've उल्टा यहाँ से लिखना शुरू कर दिया. Tan is actually, if I have to show, tan theta is the ratio of sin theta and cos theta. And if you know, the tan theta is opposite upon adjacent. How am I going to get that actually? How is it I'm getting? Sine value is what? Opposite upon hypotenuse. Cos value is adjacent upon hypotenuse, isn't it? So hypotenuse gets cancelled and I'm left with this. That's the reason I have my tan in here. Okay. Now tan is division of these two, sine and cos, right? We have just seen sine and cos ko divide kar lenge. So divided this, it becomes a 0. Dividing these two, it becomes infinity. This two, when I divide this gets cancelled. I'm left with 1 upon root 3. They both get divided, they're same, so they'll cancel each other 1. This becomes root 3. Then cot is reverse of tan in the other way. So it's infinity, root 3, 1 upon root 3 and 0. Okay. This was taught to be, this order part thingy was taught to me during my school days. But this part is like the caps and all, I have made it out. The secant is inverse of, what did I say? Inverse of cos. So whatever is there, just flip it and write it down. 1 upon 1, 1. This becomes 2 upon root 3. This becomes root 2, 2 and 0 upon 1 becomes infinity. It is not defined. You cannot actually find it out. So it's not defined actually. Not infinity, but not defined, you can write here. Okay, it's not defined. Then what is secant? We found out. Now cosecant we have to do. Cosecant is inverse of this. Either you can go with the inverse of this or you can just write the ulta for this one. Okay, secant ka ulta you can write down. So whatever is there not defined goes in here. Here also it will be taken as not defined instead of the infinity. And this goes 2 root 2 and 2 upon root 3 and 1 is what I have here. This is how I fill the complete table for trigonometry. Now, for most of the students, it's quite difficult to remember this table. So what I suggest is, as soon as you get your answer script, listen to me very carefully. In the examination, you get your answer script, right? And you get your script, okay? Once you get your answer script, on the back side of your answer script, since this is your answer script, or on the first top page of your answer script, or anywhere in the corner, make a section and write sine. You don't even have to write the full thing. Sine 0, 30, 45, 60, 90, and then fill the first ones. Okay, fill this one. 0, 1 by 2. Sorry, my daughter was answering in her class, and so I have 45 degrees goes 1 by root 2, making it stylish, and then again it's this and 1. Okay, I am writing it down, finished. Then cos, I know, inverse of this. Tan, I know, dividing these two. I can just, these are enough for me. And secant, if it is asked, I'll just flip this thing and write down. Cosecant, if it is asked, I'll flip this thing and write. Cot is asked, I can just flip it, reverse it, and I can write it down. That's the easy way to remember. And if you do not remember for the examination, if you're not willing to by heart this complete table, this would be an easy way for you to do. Okay, but you have to do it on your answer script, not on your question paper. Just make sure that you do not write anything on your question paper. So this was the first and the second exercise that we are dealing with. Then after, in the third exercise, we are going to talk about transformations. What is transformations? Trigonometric transformations is the word I'm using here. Okay, now transformations is going to be a little tricky. It's just tricky, but not difficult, but not too hard. It's just that you have to use your little brain, because we are studying mathematics for so long. We have dealt with algebra, x, y, z, and everything. So transformation will be a little more interesting, I feel, you know. And while you solve more questions of it, you will get a hang of it. Okay, now transformations require, let me just flip the page ahead. The transformations actually requires you to have a basic information about trigonometric identities. Now, identity, what is it? We have been dealing with some formulas in our mathematics, right, from a very young age, which is called as the mathematical identities or algebraic identities. What is it? A plus b whole square is equal to a square plus 2ab plus b square. And if it is a minus b whole square, it is a square minus 2ab plus b square is there. Then a square minus b square can be written as a plus b times of a minus b is what I'm doing, right? Then likewise, I have these trigonometric identities. These are trigonometric identities, okay? Trigo, as most girls and boys are willing to call it trigo. Okay, so trigo identities we are going to talk about. There are three identities. The first identity being sine square theta plus cos square theta is equal to 1. Now here, let me pay attention, bring your attention. The square is given to the sine, not to the angle. Okay, this is the first identity. The second identity is secant square theta minus tan square theta is equal to 1. The third identity is cosecant square theta minus cot square theta is equal to 1. Now, this is the only identity wherein I have the plus. The other two are, are negative. They are undergoing subtraction or differences. Now here, one more thing. If I can write this identity, I can write it as cos square theta plus sine square theta is equal to 1 only, because we know a plus b is equal to b plus a, right? Order does not matter when it comes to addition, but when there is subtraction, order plays a very important role. So how to remember this one? The second one is going in the alphabetical order, S comma T. First S and then T comes in here. It is going in alphabetical order. The third one, if I'm talking about, it is the big thing minus a small thing. So it is cosecant has 5 alphabets minus the cot, which is only 3 alphabets. So big and small you can remember it as. Okay, so big number minus a small number, that's what we have learned at the very young age, right? Always subtraction is bigger number minus a smaller number, and then as we come to 7th grade, they flip everything and they say you can even subtract a smaller number from the bigger number, isn't it? So this is what is the 3 basic identities that we have. Now, having learned these 3 basic identities, I am going to talk about transformations here, trigonometric transformations. There is proofs for this one. Okay, the proofs I will cover it in another video. You can watch it there. But how we are using these identities is what I want you to see. The first thing is, I can use this. I can write sine in terms of sine theta in terms of cos theta, and vice versa, this way as well as this way. Now let's see. Just I'm going to show you one and then we'll proceed with the questions. If I have sine square theta plus cos square theta is equal to 1 is there, isn't it? Now I want to write sine in terms of cos. That means what will it be? So I'll send it towards the other side. Sine square theta is equal to 1 minus cos square theta, and then this is sine square still. I just want sine, so it becomes sine theta is equal to plus or minus of root 1 minus cos square theta. You may ask, like, why is it plus or minus? Because when we scan this root towards the other side, it becomes plus or minus. There's a logic behind it, because if I have minus 3 into minus 3, it will be minus into minus plus. 3 3s are 9. If I have 3 times 3 also, 3 3s are 9. So if it is both minus, which is actually minus 3 whole square, no? So minus 3 whole square is also positive. Positive whole square is also positive only. So that's the reason. So the answer can be positive or negative when you are having the square being transformed into a square root. Square को मैं जब square root बना रही हूँ दूसरी तरफ भेजकर, then it is going to have a plus and minus. Okay. So now you can see, if somewhere I have sine, somewhere I have a sine, and there in the solution I do not want to, there is a sine, but I want the answer all in cos, then instead of sine I can write this thing. Okay, I can write this particular thing. That is why these identities play a very important role, and you will see how we are going to use it. For this, I'm taking one textbook question which is given as an example already. You have multiple videos solving that example. So let's take the first question from the textbook and see what it is actually. What's the first question given over here, which says that express the ratio cos A, okay, cos A, tan A and secant A in terms of sin A, okay. So cos I can write in terms of sin, I already know with the first identity. Cos and sin are having a basic identity. Starting with the solution to it, they have a basic identity. What is the identity being? Given sin square theta, sin square A, because it is talking about A, plus cos square A is equal to 1, I know. Now cos has to be written in sine, so I have to send the sine towards the other side. Sending it here, it becomes cos square A is equal to 1 minus sine square A, it becomes, okay. Now but it is still asking me cos, not cos square. So cos A is equal to plus or minus root of 1 minus sine square A is what I get. This is the first one done. Then it is talking about tan A, okay. Tan I know, but there is no identity wherein tan and sine are together. But मुझे ये पता है that tan is sin A and sin A upon cos A. Cos A I know is this, isn't it? Cos A is this, right? So it becomes sin A by root of 1 minus sine square A. Finished. Isn't it simple? Cos की जगह पर just now I got cos can be written as this. So the same thing I'm going to use it here and I'm going to write it. Finished. The second one is also done. Now the next is secant A. Is there any identity secant and A sin A together? No, we don't have it. So what we are going to do is we are going to convert the secant A into 1 by cos A. Because I know cos A and sin A has an identity, and also I know that cos A is this, so 1 by root of 1 minus sine square A. Simple as that. So all the three things have been written in terms of sine itself in here, okay. Now he asked, some students might not have understood, explaining it again. Cos को in terms of sine लिखना था. So from this identity, I am just sending it towards the other side and starting to simplify it. So I get my cos A, which is equal to 1 minus sine root of, first sending it 1 minus sine, then sending the square towards the other side, root of it becomes. Closing the answer here. Tan, how could I write? I know tan is sine divided by cos. So now cos, I am not going to sit and do the same thing again from here and get the value of cos. यहाँ पे जो value है उसी को मैंने replace कर दिया. Cos की जगह पर I'm writing 1 minus sine square. Then secant A is taken as 1 by cos A is there, which is equal to 1 by, instead of cos A again, I'm writing this value in here. So these are the values that you get for this one. Let's move to the next question. The question that is given is prove that secant A times of 1 minus sine A times of secant A plus tan A is given, which is equal to 1. So I have to prove it. And I don't see any identity being applied. Just there's this one identity that I can use, but I don't know any other thing. So first of all, let me just convert this into 1 by cos. Okay, as like you all, there are questions for me also at the age of 35 that, you know, wherein when trigonometric questions come, I also have to think of the possible methods of solving it. Okay, so this is 1 by cos A and times of 1 minus sine A. This I'm keeping it as it is, secant A plus tan A, or I want to convert it, I'll convert it better. 1 by cos A plus sine A by cos A is there, I know, which is equal to, this is what I have to prove, right? So first I'll multiply this with this one. So it becomes 1 by cos A minus sine A by cos A. Okay, and then this is 1 by cos A plus sine A by cos A. Now if you look at it, isn't it like this, A minus B into A plus B, which is equal to A square minus B square? That's what I'm going to do in here. So it becomes 1 by cos square A minus sine square A by cos square A. Now I know that 1 by cos square can be written as secant square A. And this sine upon cos is nothing but tan, isn't it? So it is tan square A. From the identity, I know that secant square A minus tan square A is equal to 1. Isn't it? I already know it. What is the identity? It is secant square A minus tan square A is equal to 1 is what I know. So the same thing ultimately is equal to 1. Hence, I have proved this thing in here. Okay. Now, but if you see the thing that is, if you see the solution that is given in the textbook is that, sorry, I'm using the flash in here. So it says that what is it doing? It's converting this and this, and then it is going on multiplying this, then it is multiplying 1 2 3 things, it is multiplying and simplifying it, and then it is trying to cross it out and then get equal to RHS. Isn't it much simpler way that it just converted this part and this part, and then I used this identity? Now some students may say that how are you using algebraic identity in this? You can use anything. You can use different methods to solve a solution, to solve a problem, because this is just a proving. How you prove does not matter, but you prove it properly using the identities is what we want. Okay, and hence it is done in here. Going ahead with this question over here, which is the example question again given in the textbook. Now again, I don't know how to solve this thing, so I'll take the LHS part. Okay, let me start with the LHS part. Okay, and I'll try to get the RHS. Sometimes it may not be possible. Okay, you start with the LHS, you will not get the RHS. तब क्या करेंगे? You are going to take the RHS separately. LHS you simplify, keep it here. RHS you take, simplify, keep it here. They both eventually will be equal to each other. Okay, that comes, but here let's start with the LHS first. Your main aim should be to start with the LHS and show that it is equal to the RHS. Okay, now let's see LHS. How am I going to write it? I'm going to write it as, this is cot inverse of this, so it is cos A by sin A minus cos A by, this becomes cos A by sin A plus cos A. Okay, then what I can do is I can take the LCM for this, isn't it? To simplify it, this part, if you just observe, hide this. Some students will feel scary, fraction and all of this is there. Hide this and see, just observe, blur it out in your vision. Okay, just observe. It's just like a fraction that I have to simplify. So it becomes cos A minus, when this multiplies with this, it becomes sin A cos A whole divided by sin A would remain here. Then I have this, which is cos A. It's exactly the same, there's only a sign difference. Sin A cos A by sin A. The denominators are same, so they'll cancel each other. I am left with cos A minus sin A cos A by cos A plus sin A cos A. Okay, now I will try to take the cos common from all of this, isn't it? I'm going to take the cos common from both of them. So when I take cos A out, I'm left with 1 minus sin A, isn't it? I'm left with 1 minus sin A divided by, again here, cos A, it's gone out, I'm left with 1 plus sin A. This cos A gets cancelled. 1 minus sin A, 1 plus sin A is what I got here. Let me start simplifying this now. I am happy with this. I'll leave it here. Let me start simplifying with the RHS thing. RHS is taken as cosecant, which becomes 1 by, this part can be written as 1 by sin A minus 1 by 1 by sin A plus 1. That further, if I want to simplify, blurring this out, I'll only concentrate on this part. It becomes 1 minus sin A whole divided by sin A, and then 1 plus sin A whole divided by sin A because there was no denominator, so I have to multiply with sin a this complete thing. Then I get 1 plus sin a. This sin a gets cancelled. I'm left with 1 minus sin a by 1 plus sin a is what I'm left with. Isn't my RHS and LHS the same? Hence I can write LHS is equal to RHS. Okay, this is the way, one of the ways when you can solve it. If you see the textbook question of it, what is given over here is, I'm sorry, I'm using the flash again. Okay, this is the textbook question given over there. Cot a minus cos a is equal to so on and so forth is what I'm supposed to show. So cot, they've written cos upon sine. Okay, and then directly what they have done is they have taken the cos common, because cos is here, cos is here. They took the cos a out. 1 by sin a minus 1, okay, is equal to, now this cos a, here also they did the same thing, only the cot they have converted. They did not even take the LCM, nothing did it. They took the cos a out. 1 by sin a plus 1 was left. The cos a got cancelled. 1 by sin a minus 1, 1 by cos a sin a plus 1 was there. And 1 by sin a can be written as cosecant a minus 1, cosecant a plus 1 is equal to the RHS. Now this thing that I showed you is 2 questions I did. 2 are from the textbook. Both of them, this is a different method that I applied. The textbook had a different method. This is another method that I applied. The textbook had another method. So this is what I want to make sure and make you understand, that trigonometry does not have a fixed solution method. It's just that you have to use it properly. You have to use your brains and then simplify it. No matter what you do, but you have to simplify it, and you can get the answer in multiple ways is what I wanted to show you. Okay.